Welcome to a new tutorial of CADSIM Plus. My name is Renaud Denzer, and today we'll cover something new. Let's start by outlining what we will learn in this tutorial. First thing I'd like to do is show you how to create a project. So that would be the combination of two drawings into your CADSIM window right here. It'll come up through different tabs, just like you do with worksheets in Excel. Then we will learn how to set up connect ins and outs so that you have process lines going out of one drawing and into another. The third thing would be to set up networks across drawings using unicast keywords. The fourth would be to have a case scenario where we would use such a network to do level control on a tank that has the controlling valve on a different drawing, so on a different tab. And then if there's some time to spare, we'll play around with tuning that level controller. I will create some shortcuts for these different stages in the YouTube video under the description, so you can fast forward to the different sections that are of interest to you. So the first thing I want to do is save a drawing as something. So like I've created a folder here called draproj, and the first thing I will do is save this drawing as ConnectOut, because from here I will have a ConnectOut going into a ConnectIn drawing. And well, let's create a stream definition for this first guy here. So let's draw a pipe and press run. It allows me to save and then to create a stream definition, as you can see from the flask here. So we'll skip ahead and just accept the defaults here for the stream type as well. And I will pick out water as a component and temperature. Let's just leave it at that. Go to the next page. We don't worry about derived variables. We could just go ahead and click finish for now, because for the purpose of the tutorial we don't really need to sort out all these details. It's asking me to specify water. I'm going to arbitrarily pick number 50, or 50 kilograms per second for the feed for water, and for temperature it'll by default give me 50 as well. So let's just accept that and click finish. And so now if I press run and observe my process line, I shall see I have 50 kilograms per second of water at a temperature of 50 degrees C going through this pipe. That's nice. And I will return to draw mode, and using this drawing create the connect out drawing. So I'm just going to basically override it. I'm going to say save it as, and call that one connect in. So I shall have two drawings that are identical. And maybe to differentiate the two, I'm going to remove the text here from the connect in, save that one. All right, so I am quasi ready here to create a project. Since I have a saved drawing, I go to File, Create Project, and I give it a name. I have to pick something. Let's call it Connect Out and In. That's the name of my project file. And currently there's only one drawing, which is the Connect In drawing, and by clicking Add, it'll search for all the drawings available in the same folder. And as you can see here, I have my draproj folder, and I have the newly created Connect In drawing and the previously created Connect Out. So what's missing is Connect Out, and let's put it in, and then we could shift that one up so it appears first, because it makes sense to say what goes out first going into the other one second. So let's hit create, and now we have essentially our worksheets, our work drawings from that draproj here, the Connect Out drawing that has the original list of tasks for today, as well as the Connect In. And so if we hit run, it should just basically mirror or be the same stuff on both sides. So we've accomplished here the first item on my list was to create a draproj. Now, we can use these things called ConnectIns and outs, which are typically found in P&ID drawings, so that whatever's flowing through one pipe ends up on the other side, on the other drawing. So to do that, let's insert a part from our process directory, and you will find ConnectOut, which is what we're looking to work with right now to send something out. And in the part opt dialog box here, we can fiddle around with the direction. So presently I want the location to be on the right, pointing to the right, and we'll keep the text above. So let's hit accept and then insert, and there we have our polygon, and we can move it around. And if I say OK, it drops it into the place and cuts a bit of the arrowhead here, and we'll give it a name. Now, how do these work? We have to select a name, say stream to ConnectIn, because we're going to send this stuff to the ConnectIn, and the stuff is the stream. So that first word has to match on the other side too. And I'm happy with that, so I'll say OK. Now, over here, when we receive the information from the ConnectOut, we need a ConnectIn. So let's do the reciprocal, which is a ConnectIn. I'll go to the part ops option, and it's pointing in the right direction. So let's click accept and insert. Let's move it a wee bit here. It's going to crop out that process line automatically, which it did. That's great. And we'll call it stream. Again, first name has to match. And we'll say from ConnectOut. So from the other page. OK. Now I'm immediately going to tell you that if I hit run, it's not going to work quite yet. So let's just test that. So let's save our work. And it's going to ask me to first specify some stuff. And I will just place the specification on the polygon. So if there is no connection, it's going to grab whatever I say I specify here. So let's put in 99, because we will probably see that. And as for temperature, let's pick another arbitrary number like 88. So let's hit finish. Now this is an over specification, the one from before, so it's asking us to delete it. So let's just do that and delete both the water and temperature and save that. Okay, now we can hit run. And when I click on the polygon from the ConnectIn, it isn't connecting. It's not connected because the simulated value is a 0 here. 0 is false. If this was a 1, it would be true for is connected. And what goes through the line is that 99 and 88, as we predicted here by putting the specification. And there's no connection here either, because we see the cross from the ConnectOut drawing, where we were anticipating to have 50 kilograms per second of water and degrees Celsius for temperature. And this is something that our users are not familiar with, although it is available in the help files, as to why this connection didn't work. And I will show you what that is. If we go into the help files, for the module help rather, the first thing to pay attention to was that the naming had to have the same first word. For example, we have fuel, we have used stream to something, and stream from something, which was connect in and out respectively. And then the next thing to be really aware is that we need to have the drawing number figured out. So to match the name right here. So they need to be paired to form a valid connection. And so to do that, we need to name the drawings. And I'll show you how to do this. In the options, tools, options, under smart connections, we need to give each of these guys, each of these drawings, a drawing name. So let's pick arbitrary names like 001. This will be drawing 001. And ConnectIn, tools, options, under smart connections, that's 002. And so we're in ConnectIn drawing, and this has to match the name of the drawing the stuff is coming from. In this case, it's 001. And if we go to ConnectOut, which is drawing 001, we are sending the stuff over to 002. That's the names that we gave the drawings. And if I press run and save that work and run simulation, I anticipate receiving 50 and 50 kilograms per second and degrees Celsius respectively from the ConnectOut drawing, which is working, and not the default values if there was no connection. Note also how the little X here is no longer here. So that's accomplishing the second part of the tutorial, which was to utilize properly connect ins and outs. Let's go back to drawing mode and begin the work to create networks across a drawing using unitcast keywords. And so what I will do to simplify a bit the things here to move faster, I will copy this first connect in, and I will use two of them. So let's paste the second one, and let's change it up a bit here. What I have in mind is to create a tank that has a certain volume in it, or a certain flow coming from this specification here, and that'll be driven out with a pump into the ConnectIn drawing, and then to do some level control. So this is steps 3, 4, and 5. All right, so let's work on step 3 first, which is to create a network across the drawings. All right, so I'm going to begin now simply by adding a tank. Let's go to the par ops, choose the smallest type of tank. We don't need reactions, etc. Let's just drop this standard tank in here, and we'll call it number 1 tank. I lost my arrowheads, so I'll put it back here. And coming out of the tank, we need a process line, and I would like to add a pump here. So let's go to the part ops, add a pump. Let's go to the options. We want this one to do nothing, and I think I'm satisfied with that. I just want this to be a pass-through pump. Let's click OK and insert. Click OK. There you go. It's a let's call it number 1 pump. And zoom in a little bit. We'll see it's a pass-through pump, so it's not going to do any calculations. It's just going to allow the flow to go through it, just like in a process diagram. And we want this to connect with my ConnectOut. So whatever comes out of there to be connected to here. And let's rename this stream, because we're using it above, to flow, for example, flow. Similarly to that, we shall change the name of this guy, thinking ahead, to level, because we're going to send a level signal to the other side. Let's hit run, save our work, and we are prompted to specify the tank, starting with its max volume. Let's select 100 as a default. That sounds good to me. The initial volume of 80 is perfectly appropriate, and a heat loss, let's go with the default, say 5% heat loss. Okay, so we are now prompted to specify the free variable flow in this pipe segment, and the whole point of the tutorial here was, or this third bullet point, was to work with flow network. So we've placed the flow network, and before I move on to this part, I'll go discuss these unit cast keywords that are quite important to for the communication between two sides, where one side is requesting a certain amount of flow. So how much do you need? And so how much this side should send over to the other side. And for that, we need some specific keywords. We can read up on them in the help files. And what I'm talking about specifically here are the unit casts match equals false and display equals flow. To emulate a flow network, the ConnectOut unit's inlet stream must know what the resulting flow at the reciprocal ConnectIn's unit outlet stream is. So this will be done using display equals flow for the ConnectOut, and the ConnectIn will take match equals false keyword. So let's play with these guys in action. So let's use them in action. Let's add a unit cast keyword to this ConnectOut, which will be a unit cast keyword called display equals flow as per the help files. And I'll pick a grayed out color here so it doesn't show up too harshly on the screen. And similarly, the ConnectIn, we have to work on that side too. So let's take a quick moment to copy this stream here, and we wanted to rename it flow, and I believe we want to add the polygon name unit cast match equals false and color 9. So this is quite important to make this work, and let's see how these two sides communicate when we hit the run button. Okay, it's asking me to specify the water. I think I'm going to equate this line here to what's on the polygon, and so I pick a linear and equate it to what's coming from the ConnectOut, And same thing for the temperature. If I put it directly over this spec, it'll directly attach with the second term here. Okay, it's happy with that. And I just missed it. I click show. Oh, right now it wants to specify. That's where we're back to specify this pipe segment, and I am pretty certain I want to create and equate to another variable. So to send to that connect out whatever's being requested here, and click finish. And this free variable I think is in case there's no connection, what should it be? And so let's put a direct setting, and by default let's say, I don't know, 44, so we can troubleshoot if something went awry. And we are in run mode. Our tank is overflowing. Let's acknowledge that. Well, it started with an overflow and then it lost all its level, but we have a proper connect in and out. So let's see, we have a true, it's happy. The flow is 50, which is 50 here. And over there we should be receiving 50. And you might be wondering, oh, okay, why is our temperature 50? Well, it's actually 47. And it's 47 because we had some heat loss. So going into the tank is water at 50 degrees, some heat loss, and so it seems to be working. But let's add now a valve over here that will control the flow out of the tank to do level control on the tank. So let's return into draw mode and fiddle around with that. Let's move on to step 4 here, level controller for a tank with the controlling valve on a different drawing. Let's start by putting an anchor point here at the top right corner of my tank. I'll go to insert part and select a meter. Let's go to the par ops for part options. That's right, I want a level and I want an outlet that's going to send a signal to the other page, and the direction is correct, so I'm happy with these selections. If I hit enter, bullseye, perfect, that's what I want. Let's call it level transmitter 1000, and I'm going to snag that signal line and expand it a little bit and come over here and steal that connect out that we had from before and place it here. So that signal line is connected to the polygon. Signal lines are process lines, and if a process line is attached to the polygon, it'll it's considered a connection. And so this looks good to me. This does not require the display equals flow stuff because it's basically mimicking the first step we did here, number 2, connect ins and connect outs. So we simply want to transfer the level of the tank over to my connect in sheet or drawing. So to do that, let's go ahead and copy again a connect in. Let's just replicate this guy. Let's get rid of some stuff here like the process lines and their specs, and rename this stream to level. And we could be a bit more detailed. We could say from where? From the tank, naturally, which means the reciprocal here was the level 2 to the controller, which we'll put in a moment. So these guys will match. And since it's a signal line, I will go into my graphics element attribute settings and select dash control, so that when I draw a process line, a dash control line, it's going to be a dotted line. And running this should ask me to specify the signal, and it does. So okay, so what is the signal if it's not connected? Let's say 0. That's fine by me. And when we click run and acknowledge these warning signs, the level currently in my tank is a 0. So that 0 is being passed on through that ConnectOut, which is connected since it has a true value, 1 equals true. And so we should see 0 over here. Beauty. So we got the level signal coming in from ConnectOut drawing. And it's time to build a valve that we will control. So in my parts, I go in the process parts libraries, select the valve, go over the options, and I am seeking a flow equals calculate valve option. I want to provide the name automatically. Flow equals calculate is a keyword that will be added at the bottom of my valve here to since there's no pressure network, it'll calculate a flow based on valve position. And I suspect that the flow here, this specification should be changed to a network. So that's why I removed it. Let's see what happens when we press run. It isn't quite unhappy here. Even though I did let's go back here, and I think I didn't remove it properly. The water, I want to remove that. Okay, I think I might have clicked restore. Let's see this. It only has the one specification, so it's missing flow, and I want to add a network flow. Ah, there it is. I think I must have misclicked something. So there is a network along this line, and as a result of having a flow network, we get to specify the valve. So we select the CV fully open. So when the valve is fully open, how much flow is there? Let's pick 100. The linearity, we can learn about this in the help files. Let's say it's 100% linearity. And its position, well, that's the thing I would like to connect to the controller. So let's not place it just yet. And it looks like this guy is hovering here, but it's along the polygon. Let's just drop it off a little bit here. And directly above this valve, let's center this valve a little bit here. Let's use a half snap. So right above this valve, I'm going to add a controller. So that's where I want it to show up. Go in my parts library, go to the controllers, and let's check out the options for a controller. So P&ID controller, let's do a computer function, and I'm happy with these settings. I'll insert it. That's where I want it, and we'll call it, I don't know, 1000. I think we use 1000. And here we can actually also change this to a level indicating controller. And the idea here was always to send that signal to the level controller and then equate the position to the output of the controller. So I think we're at the point where we should do that. So the position should be equated to another variable. So that's over here. So the position is equated to the output of the controller, which would be from that drop down menu, the current output. And we save that. So let's just run, see where we're at. Okay, now the level is 100. It's not working. We should be getting 100 over here, which we do. And the controller is doing something to the valve. Right now, the set point is 50. The set point for the level is 50, and what we're measuring is 100. And if we go into manual mode and sort of increase the opening of the valve, let's jump to 50, maybe 50.9. We're getting a bit of action here. So we made a correct guess here. So now we're actually already in the stage where we're tuning that valve. So 50.5, we're getting level. So now let's hit pause. We're getting a response. Let's go to the settings and use the auto tune function here to do a bump test. Ooh, I got a very slight response here. It's integrating control. Let's click next, hit run. It's trying it out. Let's just click finish and accept these settings and hit run and allow it to get close to our set point here. So it's overshot a bit here. So that was poor tuning actually. Ugh. I didn't expect this to oh, you know why? It's because we're still in manual. We never hit automatic. That's the solution right there. Our tuning wasn't so bad after all. Going into our settings, we can tune once more now because it's really close to the set point. So we'll get a much better response curve here. Let's go next and run again. Better tuning parameters here. Let's do some lambda tuning because it's quite the aggressive tuning. So let's double that up and run it again and see how it's a bit of a smoother curve. Let's accept that. Hit run, and now we have a properly tuned controller. So if we change our set point to say 80, our measured is now 80. So it gets and we should have on the other side a tank with proper level control. The last tip I'll give our users here is how to tidy up a bit these lines. We can press and hold down the Alt button to put this on a snap, and we can minimize the size of these specifications by going to Tool, change specification size to minuscule, and apply it to the specification icon so they kind of disappear here. And voila, we have a tuned controller whose level is being sent in from another drawing who contains the tank. And that was made possible by having a network flow through a first connect out with special unit cast keyword display equals flow, essentially providing whatever flow the match equals false keyword is asking for, well, whatever the valve is requesting flow, the amount of flow that the valve is requesting. So there you have it. I hope you enjoyed this tutorial, and if you ever have any doubts, I invite you to check out the help files, and please visit us over at ORL Systems on LinkedIn. We post over here, and our website where you can find out more about our products and services. Many thanks for your attention, and see you next time.